reality may not be solid. It may be light pretending to be matter. Welcome to Information World. Look around you. The walls, the sky, your hands, the stars above distant galaxies, everything feels physical, heavy, real. But what if the universe is not truly solid? What if everything we experience is a projection? Not a metaphor. Not poetry. A literal projection. This idea is not just science fiction. It appears in modern physics, philosophy, and even neuroscience. And the deeper we look, the stranger reality becomes. Let's begin with something simple. What you see right now is not the world itself. Your brain never directly touches reality. Light enters your eyes, electrical signals travel through your nervous system, and your brain constructs an internal model. Color, sound, texture, even the sense of time, these are interpretations. Your experience is already a kind of projection created inside your mind. But what if the projection goes even deeper? In physics, there is a powerful concept called the holographic principle. It was inspired by research into black holes, especially the work of scientists like Stephen Hawking and Gerard T. Hooft. The idea suggests that all the information inside a three-dimensional space might actually be encoded on a two-dimensional boundary surface. Just like a hologram. A hologram is fascinating. It is a flat surface that encodes a three-dimensional image. When light hits it correctly, a full 3D object appears. But that object is not really there in the way it seems. It emerges from encoded information. Now imagine something radical. What if our entire universe works the same way? What if everything we perceive in 3 dimensions is actually information encoded on a distant cosmic boundary? This idea gained serious attention through research connected to black hole thermodynamics and later developments in string theory. In certain mathematical models, a universe with gravity can be described by equations that exist on a lower dimensional surface without gravity. That means our seemingly solid universe could be equivalent to a more fundamental layer of information. If that is true, then space might not be fundamental. Depth might be an illusion. The universe might be more like a cosmic projection emerging from encoded data. And this leads to an even deeper question. If the universe is a projection, what is projecting it? Some scientists interpret this in purely physical terms. They argue that information is the most fundamental layer of reality. In this view, matter is not primary. Particles are not tiny solid objects. They are excitations of fields. And fields themselves may arise from underlying quantum information. Quantum physics already challenges our intuition. Particles behave like waves. They do not have definite positions until measured. Reality at its smallest scale seems probabilistic, not solid. When observed, possibilities collapse into outcomes. This has led some thinkers to suggest that reality behaves more like a rendered image than a pre-existing object. In a video game, the world is not fully rendered until the player looks at it. Only the necessary information is calculated. In quantum experiments, particles do not take definite states until measured. The similarity is striking. However, we must be careful. Science does not say we live inside a computer simulation. That is a separate hypothesis. But the projection idea overlaps with it in one important way: reality may emerge from something deeper and more abstract than physical matter. Neuroscience adds another layer. Your brain does not passively receive reality. It predicts it. According to predictive processing theory, the brain constantly generates models of the world and updates them based on sensory input. What you experience is not raw data. It is a controlled hallucination constrained by external signals. If your personal reality is already a projection generated by your brain, then the universe being a larger scale projection does not sound impossible. It becomes a matter of scale. Philosophy has explored similar ideas for centuries. Plato described the allegory of the cave, where prisoners see shadows on a wall and believe those shadows are reality. Only when one prisoner turns around does he realize the shadows were projections of deeper objects. Today, modern physics echoes that ancient metaphor. What we call solid matter is mostly empty space. Atoms are over 99% empty. Particles are vibrations of invisible fields. And the deeper we go, the less solid reality appears. Even space and time themselves may not be fundamental. Some quantum gravity theories suggest that space and time emerge from entanglement patterns, relationships between bits of quantum information. If space is emergent, then distance is not fundamental. It is a property that arises from deeper connections. Imagine that everything you see, galaxies, stars, planets, is like a 3D image emerging from a hidden 2D informational surface. That would mean the universe is not a collection of objects. It is a dynamic projection of encoded relationships. But here is where it becomes truly mind-blowing. If reality is fundamentally information, then consciousness may not be separate from the structure of the universe. Some researchers speculate that consciousness could be related to information integration. If both the universe and the mind are based on information processing, the boundary between observer and observed becomes less clear. Quantum mechanics already tells us that the act of measurement matters. The observer plays a role in determining outcomes. While this does not mean consciousness creates reality, it does suggest that observation is not passive. Interaction is fundamental. So what would it mean if the universe is a projection? First, it would change how we understand existence. Matter would not be the base layer. Information would be. Physical objects would be secondary, like images on a screen. Second, it would challenge our idea of space. The depth you perceive might not exist in the way you think. It could be a reconstructed dimension, emerging from encoded data. Third, it would transform our understanding of death and identity. If reality is information-based, then the question becomes, what happens to information when structures dissolve? Physics tells us that information cannot be destroyed. It can transform, but not vanish. And finally, it would reshape our sense of meaning. If we are part of a cosmic projection, then we are not insignificant. We are expressions of the same informational structure that creates stars and galaxies. But we must remain grounded. The projection hypothesis is still theoretical. It is supported by mathematical models and philosophical reasoning, but it is not proven. Science progresses by testing, refining, and challenging ideas. The beauty of this concept is not that it gives us final answers, but that it opens deeper questions. Are we seeing reality, or a rendered surface? Is depth fundamental, or emergent? Is matter primary, or is information the true foundation of existence? The universe may not be a solid stage on which events unfold. It may be an unfolding image, a dynamic, evolving projection of deeper laws we are only beginning to understand. And perhaps the most fascinating part is this: even if the universe is a projection, our experiences are still real to us. Love, fear, curiosity, wonder, these are not illusions. They are part of the projection. They are patterns within the informational structure. Maybe reality is not less meaningful if it is a projection. Maybe it is more mysterious, more elegant, more profound. The next time you look at the night sky, imagine that the vastness above you is not just empty space filled with distant stars. Imagine it as a grand cosmic display, a projection of encoded information stretching beyond comprehension. And ask yourself one question. If this is a projection, what lies beyond the screen? If this perspective expanded your mind, make sure to like this video and subscribe to Information World for more deep explorations into reality, science, and the mysteries of existence.